Okay, guys, make sure you take a picture of these notes when you have them completed, and then turn that in along with your completed assignment. I'm changing the numbering. We're just going to say 3.1. We're in Chapter 3, the first lesson on Chapter 3, so we'll do 3.1 instead of saying assignment, whatever, 17 or whatever. Okay, so we'll just change that numbering system. All right, today's about adding perpendicular vectors. Remember the symbol perpendicular? Vectors and components of vectors. So two different things, but they're kind of similar actually. Okay, we'll basically do two examples, one of adding perpendicular and one of components. Okay, so first off, vectors, just a little background. Vectors have magnitude, which is like the amount, and direction. Okay, magnitude is like the amount of it, the number part of it, and direction. Okay, so 8 newtons would be the amount, north would be the direction. Okay, that's vectors. We're starting to talk about vectors that are not like like last chapter was all about, forces. One goes this way, one goes this way. They're like parallel with each other, and then we add them together, or you'd have some going up and down. We'd add them together. Now we're saying, well, maybe they're not always going to turn out parallel with each other. You'll see on this example. All right, so let's just say a vector. It's example 1. With magnitude, we'll just do a force one, 8 newtons at 90 degrees is added to, it's kind of getting a little wordy here, vector with magnitude 10 newtons at 180 degrees. Okay, that's going to be how they're worded on your assignment there. Okay, draw it out. 8 newtons up. We're always going, well, I'll show you. 0 degrees, like mathematically, we always say 0 degrees is here. Okay, because that's kind of like the positive x direction you say. So we say 90 degrees, we're actually talking straight up 8 newtons. Okay, 90 degrees from east, you could say. Vector magnitude 10 newtons at 180, so 180 is going to be over here. Make it a little bit longer, just to kind of get it roughly to scale here. 10 newtons there. All right, so this is the picture. To add two vectors, we basically need to do this. We need to make a rectangle like that. This is not part of it. And we need to draw an arrow that goes on the diagonal of that rectangle, starting from here, always starting at this point, draw out like that. Okay, makes a right triangle. The other way to add vectors, I'll show you both of them, would be tip to tail, it's called. So you could just say 8 newtons up like this, and then from that arrow, go over and do the 10. And then the result would be going from here to the end like that. Okay, this is called tip to tail, because we basically took the tip of this vector and made it the tail of the next one. We kind of just added them up in order. This one is from a common point, or the parallelogram method. Because we're really making a parallelogram. In this case, it's a rectangle, but it's, we're going to make this parallelogram here. So hopefully you can see it doesn't really matter which way I do it. It's going to be 8 up and 10 over, no matter which way I do it. So, and we're talking a right triangle either way. So either way is fine on your assignment to draw those out. To get the answer, we're trying to figure out how long this is here or here. Pythagorean theorem. A squared plus b squared equals c squared. All right, so 64 and 100, 164, and then square root that. getting 12.8. Okay, it's still newtons. Basically, it's saying, hey, what if you had a force pulling up, and at the same time you had a force pulling over? The result's going to go on an angle. Same thing here, if you had a force pulling up, and then at the same time a force pulling to the side. Like say you're traveling in an airplane this way, but the wind is blowing to the side this way. Your plane's going to veer off like this. Okay, and it's going to have 12.8. Now, in this case, it's newtons of fourths on it, maybe. Okay, so that's adding them. You just use Pythagorean theorem, but do draw the picture out. The other thing is components. So another example of that, let's say example 2. And the one in your assignment will say something like vector has magnitude, we'll say 10 newtons, at, and then it will give you an angle. Let's do a little bit trickier one. Let's say 160 degrees. Okay, find the horizontal and vertical components. Okay, key will be draw this out. Okay, again, 0 degrees is always here, the east from this point here. So I'm going to go like 90, 180. So 160 is like, it's over here. So we're talking about this vector here. That's at 160 degrees. The length of it, or the magnitude, is 10 newtons. All right, we're supposed to find the components. So you need to make a right triangle now. Okay, up here we kind of made a right triangle because we had the legs. Now we're kind of doing the opposite. We've got the hypotenuse and we need to make a right triangle. So I could go over and up, or up and over, or I could go from like the parallelogram thing. I think the easiest thing is just to go over and up and say, okay, these are called the components. This is called the x component. This is called the y component. All right, it's just the two vectors that make up that one, is what you could say. So now we got to say, okay, well, this angle here is actually 20 degrees, right? And we got the angle, we've got side, so we're talking using trig here. All right, let's do x first. This is adjacent and hypotenuse. Remember SOHCAHTOA. Okay, adjacent, hypotenuse, we're talking cosine. So we say cosine of, I usually just do this out, something equals something over something. Okay, the angle goes here. Cosine of 20 equals adjacent, which is x, over hypotenuse, which is 10. If I solve that out, I'm going to times by 10, so it's going to be simplified out. X equals 10 times the sine of 20. Okay, I'll figure that out in a second. For y, we're talking opposite, and then we want to use this hypotenuse again. Opposite over hypotenuse, so talking sine to figure out y. So sine of something equals something over something. Angle goes here. In this case, opposite over hypotenuse will be y over 10. Okay, again, if I solve that, I'm going to get y equals 10 times the sine of 20. All right, kind of just works out nice like that because, and then I can just bop those in the calculator pretty quick. All right, so you do need a calculator that can do sine, cosine, tan. You could say, okay, you could do it step by step and say, what's the cosine of 20? Is 0.9396, and then do 10 times 0.9396, or just do it all out at once. Maybe the next one I'll do all out at once. So that one's 9. We'll round the nearest tenth, I think would make sense on these. So 9.4 newtons. That's the x. Let's just do this one all out at once. So I just say 10 times sine 20. You can just do that out in one step if you want. Y equals 3.4. All right, put those back on a picture just to make sure it makes sense. This is 3.4 newtons. This one was 9.4. That seems to make sense because this one should be longer and this one should be shorter. And they both should be shorter than the hypotenuse, which is 10. Okay, so bottom line is those two vectors, when added, it kind of adds up to that one. So it's kind of like saying you could replace this one vector with those two and say these two actually make up this one. Okay, it's kind of the opposite of what we did up here. Up here we said these two together make this one. Now we're saying find the two vectors that make up this one. So hopefully you see that they're pretty much the same idea, just opposite. Here you're trying to figure out the hypotenuse, and here you're trying to figure out what the legs are. Okay, so your assignment today is pretty much just over those two types of problems. Make sure you do turn in these notes along with your assignment. And if you have any questions, feel free to shoot me an email and we can talk. Have a good day, guys.